Today we're learning about weather fronts and how to interpret weather maps. So remember the symbols. For a warm front, if it's a colored map, it would be in red and they're half circles. The half circles can be thought of as being suns. A cold front is represented by a blue triangle. We can think of the blue triangle as being an icicle. You also have what's called an occluded front and a stationary front. And this would be the meeting of two different air masses. You notice with the occluded front it is in purple, and the symbols are facing the same direction because that front is still moving. The stationary front is alternating cold front symbol of the triangle and warm front symbol of the half circle. They're alternating direction because the stationary front is not moving. Now remember, when we look at the actual map, you look at the direction that the symbol is pointing. So if I look here, my triangles are pointing this direction, so that is the direction that the front is moving. Same thing with our half circles. They're pointing this direction. Now the general pattern of movement across the United States goes from the west towards the east. That doesn't mean that a front won't move a different direction, but the general pathway is from west to east. So looking at a cold front occurs when a cold air mass pushes beneath a warm air mass. That forces the warm air mass to rise up. You see this column of clouds. We get the cloud formation through that condensation. And right along this boundary edge as it pushes through, you have the chance for thunderstorms. And you generally will have wind. Now if we take a look at the temperature readings before the front passes through are going to be warmer than the temperature readings after the front passes through. Once the front has passed an area, the thunderstorms generally clear out, the skies become less cloudy, it becomes a generally nice day, similar to what we would associate with high pressure, cooler, drier air. A warm front is when warm air rises over the top of cold air. Now when this happens, again, you see we have cloud formation through the condensation. When we have a warm air mass rising like this, we're going to get a gentle, steady rain. This is not going to be the thunderstorms. Don't expect thunder and lightning. Just expect rain to come in. After the front passes through, you could still continue to receive rain because it is still going to be very warm, moist air. If we take a look at the temperatures in front of the storm, the temperatures are cooler. Behind the warm front, the temperatures have increased, and you have warmer, humid air. Now a stationary front is when essentially warm air and cold air meet and neither one gives in. So they're essentially kind of stuck together. So the movement is stalled and the front does not move out. When this happens, generally along the frontal boundary, you get foggy, light precipitation, generally just those bad weather days of, bad hair days, high humidity, cloudy and foggy. And it will stay there until another front moves through. Now we're going to look at weather maps. So when we look at the weather maps, we have to first look at something that's called the isobars. Remember when we talked about high and low pressure? High pressure is represented with the blue H, that's the sinking air. Low pressure is represented with the red L, that's the rising air. These lines that are on the map are called isobars. Now isobars represent air pressure. Everywhere on this line, it's equal pressure. It's kind of like the contour lines of a topographic map. Anywhere on the contour line, it's the same elevation. Well, anywhere on the isobar, it's at the same millibars of air pressure. Again, similar to what we have with the contour lines, you see how close together these lines are spaced over here near the area of low pressure. That's indicating high wind speeds. But over here, where the lines become more spread out, that indicates a more gentle wind or low wind speeds. So now we're going to take a look at some maps. So what we're looking at right now is actually a map of the current weather forecast for our area. So if you take a look at this map, you're going to see that we have a cold front passing through. Now remember the direction of the front. The teeth are pointing this direction, so the front is moving in this direction. Along this frontal boundary, you see we have an area of precipitation that could potentially be thunderstorms. And you notice it's right on the boundary, so it'll be right when the boundary is passing through. If we take a look at the isobars, right now the isobars are fairly evenly spaced. If those isobars were to become closer together, that would indicate that the wind is picking up. So looking again at the front and the temperatures that are taking place, here is our predicted forecast. Again, here's the cold front that should be passing through. You notice the chance of rain or precipitation is right here, a chance of thunderstorms. Again, as a cold front passes, thunderstorms could occur. Over here, you see we have a warm front passing through. Now look at the direction. This warm front is moving in this direction, whereas this cold front is moving in this direction. So what does this mean for our temperatures? So if we take a look at our current forecast for temperatures, you see before the front gets here, our temperature is predicted at 79. The back side of the front, the temperatures are lower, 67, even upwards of 40, where the front has already passed through. So your temperatures before a cold front are warmer, after a cold front are colder. So when you look at a weather map, first identify what type of front you're looking at, what direction is the front moving, and then think about what would be the weather before the front, during the front, and after the front.